Okay, so today in this video, I'm going to show you guys how to multiply together two binomials using the FOIL method. So let's get into it. So starting with one binomial, we'll do x plus 7, and then multiplied by our second binomial, x minus 3. So what we're going to be using is a method called FOIL. So FOIL stands for first, outside, inside, last, and it's a multiplication order for how we want to multiply these binomials together. So first means we're multiplying together the first in each parenthesis. Outside is the outside term in each parenthesis. Inside is going to be these inside terms here in each parenthesis. And then last is going to be the last term in each parenthesis. So anywhere you see these lines connecting, they're going to be multiplication pairs that we're multiplying together. So I'll show you guys. So starting with this line that's connecting the x and the x times x is going to be x squared. This next one, which is going to be our outside multiplication pair, is going to be x times -3, which gives us a -3x. Our inside pair is 7 times x, which is going to be a positive 7x. And then our last pair is going to be 7 times -3, which is going to be -21. Now we're almost done here, but we can still simplify this a little bit by combining any like terms. So notice here in the middle, we have two x terms. We can combine those together. So we're going to rewrite this x squared and then combine -3x with a positive 7x to give us a positive 4x here, and then finish off with a -21. So this is going to be our complete answer. And then we'll give it a nice good green check mark there. Alrighty, you can pause the video if you want. I'm going to erase this if you'd like to see my work. And we're going to do just one more example, and I'm going to make this a special example because this sort of thing comes up a lot. Oops. Get the right color here. So this next example, we'll do x minus 3 and x plus 3. So again, we're going to FOIL this. And this particular example is actually what's called a difference of squares. And I'll show you what that means here in a sec. So again, we're doing the first, outside, inside, and last multiplication pairs. So starting off with the first multiplication, x times x. That gets us our x squared. Then x times 3 is going to be 3x. -3 times x, -3x, and -3 times 3, -9. Same thing, we want to combine any like terms. So x squared stays the same. 3x minus 3x will leave us with 0x in the middle, and then -9. So this is our final answer. And this is what's called a difference of squares, because x squared and 9 are both perfect squares, meaning that x times x will equal x squared, and 3 times 3 will equal 9. So it's a difference of squares because there's a subtraction sign. That's where the word difference comes from. So the difference of two square numbers. So this is a pretty common example that you'll see quite a lot in mathematics.